Okay, let's get some review. Okay, so we talk about linked list. Okay, linked list is very important, especially when using the linked list. Um, we do not is compare with array list. Linked list they can optimize the memory space. Okay, because we give like example array list if this is the memory space. Okay, once you declare this is for array A, okay, you cannot easy to extend this array A over here. Okay, the reason is the rest of the space most of the time is occupied with other um, process and maybe other applications, which means it's not easy to directly to find the list position for the A to extend. Okay, but compare with the array list, okay, this is very different. If we compare, this is memory space. For example, this one is A, okay, and this part is B, and this part is C. Okay, what we can do is if we want to combine them together, okay, if it's for example this is for the array, okay, you have to declare a new one, right? Let's change another color. Okay, for example, this three space, okay, for the temp one, okay, then you need to copy A and B and C into this temp one, right? Okay, but for the linked list, it will be very different. Okay, for the linked list, the only thing you need to do is that using another color. We link them together. For example, you just link A point to the B, B point to the C. Okay, once we link them together, we know for example, they are extended. Okay, if we remove some of them, which we can see we just remove, we shrink the size. Okay, so in the linked list, this very important part is the first you need has a node. Okay, so for example, A and B and C, they are a node. In a node have two very important components. Okay, first we need a node ID. Okay, this should be maybe it's a name, right, or something to identify this node. Another thing is the next node reference. Okay, next node reference. This one, it will point to the next one you want to link it. Okay, in the lecture we gave like example about the hand, right? So for the hand, they only need to know who will grab your hand, who's the next hand to you, right? So this one will be the next node. Okay, then we link them together, which we link a node together, which we called linked list. Okay, so linked list, we link A, B, C, okay, together if we want to link them together. So this one, the next have to link B, and the C have to link C. And for the tail one, it's just a point to the noun. Okay, so this is the idea of linked list. Okay, so in a linked list, we explain different method. Okay, the method is one method is we called is insert. Okay, insert first. Okay, so if we have these three different node, Okay, we link them together. Insert first means we want to insert a new one. Okay, for example, it's n. Make this one to the link. Okay, and make this new one as the head. Okay, if we do the insert last, okay, it will do very differently. Okay, so A, B, C over there. We link them together. Okay, if we want to link the new one over there, for example, this is again. So first we need to make sure the previous tail, okay, this none you need to change to the new. Okay, so this one we change to the n. Okay, and for the n is point to nothing, right? We make a nexus with a none. Okay, then we talk about the remove one. For the remove one, we talk about three different methods. Remove first. Okay, if we have this three node, so connect them together is connect together is a linked list. So if we want to remove first, we just need to do is we just make this link gone, right? So how to do this? We just change next to the none, right? So and move the head to over here. Some of the people they just they don't even care about the head one, you know, they don't change the none, they just directly to make the head to the next one. Okay, so this is another idea because we only care about the linked list, right? So no matter they are linked or not, so if a head will be the second one, okay, so basically we remove the first one. Okay, so another one we call this a remove last. Okay, so the same idea over here, we have three of them, we connect them together. If we want to remove the last one, what we can do is change to this one, okay, to the none. Okay, so the tricky part is you need there's a one example we gave is you have to find where is the last one, which one is the last one. Okay, and because in the linked list in our example we didn't declare the tail one, which means if you want to remove last one, first you need to search the last one, right? So the last one there's very very identical condition is the last one, the next node always point to the none. Okay, this one will help you to find the next one, right? The last one then will help you to find the previous one, right? Because previous one when the sets the previous one's next is none, right? So this is an important part. Okay, then we talk about remove search one, right? For example, this is ID. Okay, so it's very similar to the remove last. Okay, what you need to do is you need to find this one. For example, it's the middle of the middle of the linked list. You need to find this ID. Okay, how to find this ID? We keep looking for. Okay, so if this one, for example, this is B. Okay, we're looking for the name of the node. If the name is node is B, so we need to keep track, okay, will be previous one, who will be the next one, right? Once we know these things, we make a previous one to the next one, point to them. So obviously this one just begun, okay? So then we talk about a new idea, two new different data structure, okay? One is queue, okay, another one is a stack, okay? So for the queue, the principle is, if you don't remember, it's fine. You just keep in mind the queue is the waiting list, right? If it's waiting list, the first in always be out, okay? So for the stack, if we just consider this is the stack game, right? So if we want to get the last one out, okay, you always be take the top one first, okay? So this is means the top one always last one in, right? Last in, right? This is last one. Okay, so since we want to, so we talk about three different operations to the queue and the stack, right? For the queue is in queue, right? So I just simplifies, and the dequeue and the pick. Okay, for the stack, we have push, we have pop, we have pick. Okay, for the in queue means we want to add one more. Okay, if you consider this is waiting line, if you want to add one more people, they always come to the last. Okay, if for the DQ one, we first in and the first out, which means the head of the line, they will go first. So DQ will remove the first one, right? So pick one will just return the first one. All right. So the stack, we want to add one more, which means is if we want to add more over here, say okay, they have to be in the top of the stack, right? And the pop one means we want to the top of stack get out, okay? And for the pick, we don't return the top of the stack, okay? Obviously, we can consider we can consider these three operations can be inherit some method from linked list. Okay, this is kind of we talk about the things like reusable. Okay, we can reuse some method which we already write in the linked list. Okay, this is the reason we can just using the interface. Okay, so let's take a look if we want to do the queue. Okay, for the Q1, since this is the linked list, so linked list we connect them together. Okay, if we want to enqueue, okay, we just need to add one more and make this point to a new one, right? Obviously, this one is insert last, right? If we want to do the DQ means we want to remove the top one in the first one of the line, right? So obviously we want to remove the head. Okay, if we want to remove the head, it's using the method remove first of the linked list. Okay, so the pick one, you just return the head as well. Okay, for the stack, since we consider this is a stack, so we can look the linked list in this way. Okay, the top one is the head one, right? So that if we want to do the push means we want to push a new one, right? So if the stack, the push always be top, right? So this is we consider insert first. Okay, if we want to do the pop one, we want to remove the first one, right? So remove the first one, we just call remove the first of the linked list. Okay, for the pick, the same thing, we just return a head. Okay, so these three things we're using the interface and inheritance in this code implementation. Okay, you compare this code, you can see you can find out the why we should use the interface. It's help you to do independently inherit or using some code which already be done or tested or written. It's very easy. It's not highly dependent on each of the method, right? Specific method, since we're using the abstract method and the inheritance. Okay, so this is for the data structure chapter. Okay, everything will include in the video. Make sure you read it, you read the book and review the PowerPoint and the video. Okay.